In this lesson, we're going to be talking about rational exponents. But to do that, we need to start with a review of the root of a number. The root of a number is basically an opposite idea to taking a number to a power. Square root 9. So the square root of 9 is how this is read. The root is the number that when squared yields the answer 9. So since 3 squared equals 9, the square root of 9 is 3. Here's another one with the cube root of 8. The root here is the number that when taken to the third power yields the answer 8. So 2 cubed equals 8, therefore the cube root of 8 is 2. There is an exception in that you cannot take a square root or any even root of a negative number and get a real number answer. Here we have the square root of negative 4. There is not a number that when raised to the second power gives us negative 4. Two negatives would make a positive, so it just isn't possible. For any case of a negative even root, we would say the root does not exist. The fourth root of negative 16 does not exist, because again, there is no number I can take to the fourth power that will give me a negative 16. Here's another example. The sixth root of negative 64 does not exist. Odd roots in other situations, you can take an odd root of a negative number. The cube root of negative 8 would be negative 2, as negative 2 to the third power is equal to negative 8. You can have a problem such as the negative or opposite of the square root of 16. Here, the negative is like having negative 1 times the square root of 16. So you would get the square root of 16 is 4, and then times by negative 1. So the final answer in this case would be negative 4. Now let's begin with rational exponents. Roots can be written with exponents, but they are rational exponents, otherwise known as fractions. The square root of 4 would be written as 4 to the 1/2 power, where the 2 in the denominator represents the square root. Cube root of 8 would be written as 8 to the 1/3 power. The cube root of negative 8 would be written as negative 8 in parentheses to the 1/3 power. This form is very useful when solving many algebraic problems. I'm going to have you rewrite the following from radical form to rational exponent form, and then the bottom two you're going to rewrite from rational exponent form to radical form. So pause the video, give these problems a try. When you are done, restart the video, and you can work through the examples with me. The first one is the square root of 4y. Now since both the 4 and the y are underneath, I'm going to be putting those in parentheses to show that 4y together is being taken to the 1/2 power. Yes, you could have rewritten it as 4 to the 1/2 and y to the 1/2. That would be the same thing. The cube root of b. So again, cube root is 1/3 power. I'm simply going to write this as b to the 1/3 power. And the third one, the 7th root of 2, I'm going to take 2 and the 7th root, so 7 is the denominator, 2 to the 1/7 power. Now we're going to take the rational exponent form and put them into radical form. So 3 to the 1/2 power is simply saying this is going to be the square root of 3. Now in the second one, I have 2x to the 1/4, but notice that there is no parenthesis around the 2x, which means that the 2 is not being affected by the 1/4 power. Only the x's. So this would become the fourth root of x times 2. Let's do some more with rational exponents. Rational exponents are generally written in p over r form, where p stands for the power and r for the root. So I can write the cube root of 2 to the fourth as 2 to the 4/3 power, or the fourth root of x to the seventh as x to the 7th over 4th power. You'll notice that the power, the 7 and the 4, were written in the numerator, and the root is written in the denominator. Now here's a problem I'd like to evaluate 8 to the 4/3. So I would break it out as 8 to the 1/3 times 4, or excuse me, to the 4th power, because if you remember, when you have a power to a power, you're multiplying the powers. So 1/3 times 4 gives us back to the 4/3. So by breaking it up, I can now do the cube root of 8, which is 2, then take the 2 and raise it to the 4th power and get 16. If we need to simplify the following, say the square root of x to the 5th, y to the 6th, rational exponents are very, very important. So I would change each to rational exponent form. So x to the 5/2, y to the 6/2. Now I'm going to use some old arithmetic to simplify this. For the x, 2 goes into 5 twice with a remainder of 1. So my x turns into x squared times the square root of x. So since 2 went into 5 twice, that's why I have an x to the 2nd power on the outside. For the y, 2 goes into 6 evenly 3 times with no remainder. So my y goes from y to the 6th over 2 to y cubed. So together my answer is x squared y cubed times the cube root of x. Any remainder we get, such as the 1 with my x's, will always remain under the radical sign. Now let's have you try, again changing these first for the variables into rational exponent form. As for the numbers, you should just be able to take the root of each number. So pause the video, give these a shot to the best of your ability, then restart the video and work through them with me. Let's take a look at the first example. Simplify x square root of x cubed y to the 8th. Now this is the square root, so I'm going to be changing these into power over root form. X is going to be raised to the 3rd over 2 power cubed over square root. The y I will convert to 8 over 2. So now I'm going to take a look at the x. I know that 2 goes into 3 one time. So that means there's going to be an x to the 1, or first exponent, outside the radical sign. But there is a remainder. 2 goes into 3 once, but it has a remainder of 1. So my square root symbol has 1x remaining left over. Now the y, 2 happens to go into 8 evenly 4 times. So that 4 is the exponent that comes out with the y. There's no remainder, so there's no y that stays under the symbol. So your final answer is simply x, y to the 4th, times the square root of x. Now let's take a look at the second one. Now again, with the numbers, we can just deal with those. So I'm going to take the square root of 4, because I know that's going to be 2. Now I'm going to focus on the variables, and I'm going to change those to rational exponent form. So let's start with the a. The power is 2 over the root of 2, because it's square root. The y has a power of 3 over the root of 2. So now when I simplify those, I see that, okay, I have a 2 on the outside because that was a perfect square. 2 over 2 reduces to 1, so 1a comes out, no remainders. But with the y, the 2 goes in there one time, so a single y comes out, and it does have a 1 for a remainder, and that is why I have 1y underneath. The last problem is a cube root. Again, in this case, the cube root of 8, it's a perfect cube, so that's going to get me a 2 on the outside. Now I'm going to recreate and take this x, put it the power 6 over the root of 3, take the y, power of 9 over the root of 3. So we have 2 on the outside. X, let's see, 3 goes into 6 twice evenly, and there's no remainder, so no x's stay under. 3 goes into 9 for the y 3 times, so y cubed, again no remainder. So there is no radical sign left for us to have. It's just 2x squared y cubed.